So we are gonna wait and give everyone just a little bit of time to get in here. So gonna give everyone maybe about another minute or so before we get things started. But we are gonna wait a little bit before we start things up here. Okay, let's go ahead and get things started. So to start things off, I want to start off by kind of explaining how I want to, do this class. So first off, hello, my name is Kitong. I don't know, I think most of you guys are new faces to me. So you guys can call me Teacher Lou, teacher, anything like that. I don't really mind. It's not a really big idea. It's not a really big deal to me. But the general idea here is I'm going to be teaching this class for you guys. I've actually been teaching this class ever since last year. So last year was the first time we did this. This is going to be the second time around that I'll be teaching this class. And for this class, what I want to do is I want to, I want to have you guys help out a lot, right? So as we go through the textbook, there's going to be a lot of problems in there. And as we work through the problems, I don't want this to be, just me working out every single question. You guys may be listening, right? I don't want to do that, right? I want to call on you guys. I want to have you guys work them out. And if you guys aren't sure, always ask for help, right? You guys can say, "Oh, I'm not sure about here," or "I don't know about this," right? Or I can't remember. Anything like that's perfectly fine, right? That's perfectly understandable. But what I want you guys to do is I want you guys to try, and I want to hear you guys think, right? I want to see what you guys can come up with. And that's the big idea here, right? So we're gonna have, all these questions, right? All these questions will be worked out by one of you. And as we move through the textbook, right, as we move through this, I'm going to talk about, the big points, but for each individual problem, that will be for you guys to work out. I'll call, most likely what's going to happen is I'll just, go down a line or, call on people one by one. But as we move through the problems, right, you guys will be the ones that will work out all the problems. And when we go through these problems, right, if there's any questions that you guys have, if any of you have any questions, please make sure to ask. As we go through the problems, I'm going to ask many times, right? Does anyone have any questions, right? Something along those lines. If you guys have a question and you're afraid you're going to forget before I, get to ask that, please, one thing you can do is, since this is an online class, you guys can make sure to, drop, just put a message in the chat, right? There is a chat box. If you guys use it, then I'll be able to answer any questions there. And also, if you guys don't want to ask everyone, right? If you don't want to ask in front of everyone, if you're a little shy, any reasons like that, right? What you can do is you can ask me directly. So instead of sending that message to everyone, you can see that there's an option that says to and then just me, right? So to just the host, right? So when you're doing that, right, send your question to just the host, and then I can answer your question without anyone else knowing who asked it. Now, I will need to read out the question out loud so everyone knows what the question I'm answering is, but I won't say who asked the question. So that's that's something that you guys can do as well. If you guys have a question and want me to know, but don't want to type it out, but like do want to ask it directly, you can do something called raising your hand, right? So that's under the reactions. So towards the bottom of the screen, there should be a reaction button, and one of the buttons that you can press on there says raise hand. And if you raise your hand, you'll get pushed up to the top of the meeting, to the top of the participant list, and I'll be able to see that you guys, whoever it is, raise your hand, right? And that means that I know, okay, you have a question that you want me to answer, right? Sure, go ahead and give it a shot right now. Give it a try, see what that looks like. But that's what that does, right? So then I'll know, okay, this person has a question, I'll know to answer you, right? Another thing as we go along is so since I am going to be answering calling on you guys one by one, something I will ask you guys to do is if you have a name that you go by that's that you want me to call on, right? Make sure that that's what your display name is. So if that's not what your display name is, go ahead and change it to that, or you can ask me to rename you, anything like that. But if there's something that you want me to call you by, that's what I'll go off of. I'll go off of whatever your name is on Zoom, right? And lastly, one other thing is cameras. So I actually don't require you to use cameras. I actually would prefer you not to. The reason being is because as we go through this book, I'm going to be sharing screen. I'm going to be sharing an iPad screen, and I'll be writing all over it. I'll be showing the problems on it. But the idea here is I want you guys to be looking at my screen. I don't want you guys to be looking at each other, right? I want you guys to be looking at my screen and only my screen, right? So for that reason, I would rather you not actually share video, right? Because I find it a little bit distracting, actually. From the meetings that I've been in, from the Zoom meetings that I've always been a part of, if I saw that my camera was turned on, I was always looking at myself rather than looking at anything else, right? So for that purpose, for that reason, I want you guys to, I would rather you guys not share, right? Now, because of that, I can't tell if you're listening or if you're watching, but that's why I call on you guys, so that when I do call on you, right, you better be listening, because if you haven't been listening, then you won't be able to answer the question, right? So that's a couple of things, right? Please make sure, right? Please do pay attention. If you guys, if you have a mic that doesn't work, or if you don't want to answer a question, please just let me know. That's perfectly understandable. I can get it, right? Maybe some people are just a little bit more shy than others, would rather not. I can understand that. If you don't want to answer a question, or if you're if you're outside and just listening and the connection's a little bit bad, just for any reason, right? If there's any reason why you don't want to answer a question today, just let me know at the start of class. Send me a message, let me know, hey, please don't call today, and that's fine, right? I can understand that. Maybe your mic's broken, I'm not going to ask you exactly why. That's totally fine. Just let me know at the start of class so I know not to call on you, right? I would much rather you tell me rather than me call on you and then just like wait for a couple of seconds as I try to see if you're here, right? Another thing is, if you need to use the restroom, or if anything happens, fire alarm, anything, right? If anything happens that requires you to walk away, right? Just let me know. That's perfectly fine. Right? We do always record the lesson. So if you have to go use the restroom, right, anything like that, just make sure to watch over the portion that you missed, right? So that's something else, right? So if you need to go, just go. Let me know you're gone, so I know not to call on you while you're gone. But apart from that, that's really about it here. So if you for any reason, right, just let me know if you don't want to be called on. Okay. Yeah, those are some of the big things that I wanted to cover. One last thing is Padlet. So if you guys have seen the Padlet, if you guys have access to the Padlet, what we're going to do there is each week as we go through the material, we're gonna post more things on the Padlet, right? So on the Padlet we have everything posted from the actual book itself to the homework from each week, right? So as I'll actually share screen here. But if you can see here, right, we have the Padlet, right? We have the material here. Right now, there's not that much, but the idea here is we have the chapters from the actual book as well as the solutions to the problems. And then each week we're going to post what the homework is as well as the recording from that week here. So so after this week, right, once we're done for today, we're going to have the homework from today as well as the recording listed here. So that's going to be something that you guys want to be familiar with. Make this, make sure that you are familiar with this Padlet. That's going to have everything that you're going to need to do this, to follow along with this class with. Yeah, so that's the majority of what I wanted to make sure to cover. I guess any questions before we start? Any questions about any questions about how I want to structure this class? Any questions about how far we're gonna go? Anything like that, really, I guess?
Are you gonna close the waiting room and just turn the waiting room off?
So after this first class, I think we are. But
yeah.
For have it, yeah. Any other questions? If not, then
how are you gonna teach?
How am I gonna teach?
Yeah.
Through Zoom. I mean, well, I guess the answer to that is, I guess you'll see. We're about to start. Apart from that, though, I mean, I kind of did explain earlier. As we go along, right, there's going to be many different questions in this book, and we're gonna teach along through those questions, right? So I'm gonna ask someone to work out one of the problems, and then after that we'll talk through the important details, like, okay, why did we do this problem, right? What is there to learn from this problem? But that's the idea here. Anything else? If not, then that's going to be about it here for the startup part. So that brings us to why pre-algebra, right? So what even is pre-algebra? So pre-algebra, as a bit of a background, pre-algebra tends to be the class that you take between elementary school and middle school, right? So middle school is when you start learning about algebra. Middle school, that's when that's one of the classes that you'll take there. And elementary school is when you're really learning about arithmetic. Elementary school, you learn all about addition, subtraction, multiplication, division, things like that, right? But as you move on, you definitely learn more than just that. But those are the basics of the basics, right? So what pre-algebra does is it's kind of like the bridge between the two. It's like telling you how to get from that arithmetic part to the algebra part, and what you can do with all of what you've learned so far, right? So what pre-algebra really is, it's sort of like a way to kind of consolidate that information. It's a way to bring all of that together and say, okay, well, this is how we can put it all together, right? So that's the big idea here, right? So that's what we're going to look at here. We're going to look at a lot of different ways to solve questions, a lot of different ways to work out different problems. And pre-algebra is one of the most important books in the entire group series, right? Because pre-algebra, everything that we do here is used later on. Now, pre-algebra and algebra cover a lot of the same material, especially in the early portions of the pre-algebra book. But what you're going to find is that in the pre-algebra book, especially the later parts of it, you're going to find introductions to things like geometry or introduction to things like statistics. So the pre-algebra book, what this really does is it kind of gives you an introduction to most of the other classes. And that's going to be what we're going to look at here over the course of this full year, right? Over the course of this semester and next. Okay, so in chapter 1, what we're going to do is we're going to do a lot of review. Chapter 1 is really all about the reviews of the rules from arithmetic that you should have remembered. Because those rules should be stuff that you learned all the way back in elementary school. And the idea is we want to use those rules, we want to remember what they are, and we want to be able to apply them to what we do later on in this book. So in chapter 1, That's what we're going to look for. And we're going to kind of set up how we look at these things, right? So a lot of things that we're going to do in this book, we're not going to just say why. We're not going to only tell you, how it works, right? We're not going to just give you a formula. We're also going to see why it works. We're going to see why this, formula is the formula. We're going to see how we got this formula. And that's going to be, a lot of the things that we're going to do here. Okay, so with all that being said, it's time to screen share. So one of the most important things before we kind of get things started, right? We're going to be working with a lot of numbers in this book, right? So the first thing that I want to do, I want to kind of talk about the different kinds of numbers that there are, right? So as we work through the different problems here, right, we need to understand what we're working with. And one of the things that we need to understand is exactly what are the numbers that we're working with here. So that's going to be one of the first things that we need to answer, basically. So hopefully you guys are all familiar with a number line, but a number line is simply just a line that goes from left to right, and we put numbers along it, right? So the numbers to the right are numbers that are bigger. So for example, if I put 0 right in the middle, as I move to the right, I'm going to get bigger and bigger. So for example, 1, 2, 3, and so on and so forth, right? The line goes on infinitely. So what that means is that these numbers go on infinitely towards the right. We also have numbers to the left of 0. Those numbers are what we call negative numbers, right? So negative numbers, -1, -2, -3, and so on, right? So a number is called positive if it is to the right of 0. And you can think of that as just being greater than 0, means it's positive. Negative means it's to the left of 0 or less than 0. However, since 0 is neither positive or negative, right? Since 0 is neither greater than 0 or less than 0, that means that 0 itself is neither positive or negative. You can also use the words non-negative and non-positive, I guess. You won't really hear non-positive very much, but the idea is that non-negative does include 0, while positive does not. So positive refers to 1 and up, non-negative refers to 0 and up. That's the big difference here. You may also see words be called non-zero. That just means it's anything except 0. So this is, some of the differences between the different words that we will use to describe numbers. Lastly, over the course of the first couple of chapters in this book, we're going to be looking at mostly integers. But what exactly are integers? So first off, you'll see a lot of words, you'll see a lot of different ways to classify numbers. The most restrictive of these is what are called natural numbers. Natural numbers are numbers that you can count with. So for example, 1, 2, 3, 4, and so on and so forth. This goes on and on and on. However, a little bit more than that is what are called whole numbers. Whole numbers also includes the number 0, typically. Depends on where you see this definition, but in this book, we're looking at whole numbers as non-negative numbers. So 0 all the way up, natural numbers is only positive, so 1 and all the way up. Okay? You may also see, apart from this is the big one, integers. So integers are going to be the whole numbers as well as the negative versions of them. So integers are also going to include -1, -2, and so forth all the way to the left as well. So 0 all the way down and 0 all the way up. These are going to be your integers. For the early chapters of the pre-algebra book, this is what we're going to be working with for the most part. For chapter 1, we're actually going to be working with whole numbers a lot more, but we will see integers eventually. So these are going to be what we're going to work with for the most part. There are numbers apart from this. What you'll notice so far is we have not seen any fractions. We have not seen pi, anything like that. Those are other kinds of numbers that we will talk about in later chapters. But to kind of give you a little bit of a sneak peek, there are rational numbers and irrational numbers. Rational numbers means that I can write this as one integer divided by another. So for example, 2/3 is considered a rational number. I can write it as one integer divided by another integer. You'll also know that every single integer is also a rational number because every single integer can be written as itself divided by 1, which is an integer divided by another integer. And an irrational number would be just numbers that cannot be written as a rational number, numbers that cannot be written as a fraction. A really good example of this would be something like pi. Pi, if you are familiar with this, is 3.14, 15926, goes on and on and on, right? There's no pattern in these numbers, right? That's why it's such a big deal to memorize digits of pi, because there's no pattern in the digits that you see here. So as you go on and on and on, right, these digits do not repeat, do not have anything, do not have any pattern whatsoever. So that's going to be what's called an irrational number. There are actually more numbers than just this, but for the purposes of pre-algebra, this is as far as we need to go. Any questions over the categories of numbers? All right. If not, then that leads us into section 1.2.
What's the highest irrational number that we know?
Highest irrational number that you know?
That we know.
Well, there is none, right? There is no highest one, because if you add 1 to it, it just continues to be higher. So there is no irrational number that is the highest one, because you can just continuously keep on making it bigger. Anyways, so for section 1.2, this first arithmetic operation that we're going to look at is addition. So there's not really that much that we really want to look at here, but there is going to be a very important topic that we talk about here for addition. And we want to set this up with the two properties of addition that we should know from arithmetic, from early on, like what you work with in elementary school. So let's see if you guys remember. So starting up, we have problems 1.1 and 1.1 through 1.4, actually. Let's take a look at these problems. All right, problem number 1.1. Let's hear from Mindy. Let's start from you. And if I call on you, please start by reading the question. So, sorry, go for it.
Using the pictures below, explain why 2 plus 3 equals 3 plus 2.
Mm-hmm. So what do we have here?
On me?
Yeah. When I call on you, right, you're gonna be responsible for both reading the question as well as answering it. So what do we have here?
There's a 5 block group, I guess. I could explain that way or describe it. There's 2 of them, which equals to 10 in total, 10 squares or 10 cubes.
Well, basically on the left side, we have 2 blocks in the first row and 3 blocks in the second. That's the 2 plus 3, right? And then on in the second group, we have 3 plus 2 in the opposite order, right? But both of these have 5 blocks in total, right? That's the general idea here, right?
Yeah.
Okay, so my question for you is, why? Like, what's the idea behind this question then?
It's basically switching the order of the 2 numbers.
Yeah, and the idea here is if you switch the order in which you add numbers, it does not change the sum, right? It does not change the answer that you should get. So even if I add 2 numbers in a different order, I should get the same answer. Do you remember what this property is called?
Well, I don't really remember the property, but if I take a guess, is that commutative?
It is. It's the commutative property of addition. So this is called the commutative property of addition. So what this says is no matter what, if I add 2 numbers in different orders, I still get the same answer. So in this case, right, A plus B is equal to B plus A. So these and thanks, Mindy, right? So for these 2 letters, right, what these represent are just 2 different numbers, right? So you can even think of this as number 1 plus number 2 is the same thing as number 2 plus number 1, right? I'm just adding together 2 different numbers. It does not matter what order I add the 2 numbers in. No matter what, it's the same sum. And that's what we're working with here. Any questions over this one? So for any two numbers, it does not matter what order I add the two numbers in. Now, this on its own doesn't actually do very much. But when we include this with the property from 1.2, we're going to get something really important. Let's take a look at 1.2. Let's hear from Audrey.
Okay, using the two pictures below, explain why 2 plus parentheses 2 plus 3 plus 4 equals 2 plus parentheses 3 plus 4. And reminder, if the parentheses tell you what to compute first. For example, parentheses 3 plus 4 times 5 equals 7 times 5, whereas 3 plus parentheses 4 times 5 equals 3 plus 20.
Mm-hmm.
So, 2 plus parentheses 2 plus 3 plus 4 equals 2 plus parentheses 3 plus 4, because it doesn't matter which with addition, parentheses don't matter because they're put into the same order, I think.
Okay, so what you're saying is it doesn't matter which two numbers you add together first, right? We can regroup the numbers, add them in a different order, and we should still get the same answer. Is that what you're saying?
Yeah.
Yeah, and if we look at here, right, in this first example, in this first group on this left side, right, we have the 2 plus 3. They're the groups of the lighter boxes, right? And then over here on the right side, right, these are the groups of the shaded boxes, right? 3 plus 4, right? So the idea here is in total, no matter what, right, you still have a total of 9 boxes, either on the left and on the right, right? So the idea here is it doesn't matter what order I add the numbers in. Do you remember what the name of this property is?
I think associative.
It is. So this is the associative property. So the associative property and the commutative property, what we can do between both of these two questions is as long as everything that we are doing is addition, it doesn't matter what order we add the numbers in. No matter what, we can change around the order of the numbers in any way we want. Because no matter what, we can do either something from the associative property or from the commutative property to get what we want to get eventually what we want to see. Now, the reason why this is important is because sometimes the question might be worded in a different, in a really weird way. For example, we're going to see in both problems 1.3 and 1.4, we're going to get some questions for addition that seem pretty difficult, especially the way that they're actually listed. But if you change things around, you can get something much, much simpler. But that's exactly it here for question 1.2. So this idea that you can add together numbers in any order you want, this is what's called the any order principle. Sometimes, people will mix up the different commutative and associative rules, right? The properties, they'll mix up the names here. But I promise you, the names themselves are not very important. What's much more important is understanding why you can do this. The idea is as long as you're adding together numbers, you can add them in any order you want. But remember, you must be only adding numbers. If you're doing anything else, you have to make sure you're following the rules. Okay, let's take a look at 1.3. Let's hear from Alan. 1.3. Alan?
Okay. Using the properties from problems 1.1 and 1.2, explain why 472 plus quotation 219 plus 28 equals quotation 472 plus 28 plus 219.
So these are parentheses, by the way, not quotation. Quotation is this. Okay, so why are these two things equal?
Because they're still the same numbers.
Mm-hmm.
They're switching orders.
Yeah, all we've done here is we've changed the order around. We've changed the order in the numbers that we're adding together. And as long as all the numbers stay the same, as long as we're still adding up every single number, it doesn't matter what order we add them in, right? So the idea here is instead of doing, 219 plus 28 first, we just do 472 plus 28 first instead, right? And that, is the same thing. All the same numbers show up, they're still being added, so everything is still the same. If we really want to be, very, very specific about the details, right? What we can do is we can say, okay, so for 472 plus 219 plus 28, we can say, first off, we can use the commutative property to change the order of these two numbers. That would give us 472 plus, in parentheses, 28 plus 219. So all we've done so far is we've changed the order of the two numbers in the parentheses. Then so that was the commutative property. And then from there, what I can do is I can change my parentheses. I can make this 472 plus 28 plus 219, but instead my parentheses are here. What property is this, Alan?
I think it's still commutative.
This one's not the commutative property anymore. The commutative property means I actually changed the order of the numbers. That was from here to here. I did that right here. But here I am changing the position of my parentheses. And that is actually the associative property, right? Remember, associative means I'm changing my parentheses placement. Commutative means I'm changing where my numbers are. So this one is associative property. Does that make sense?
Yeah.
So between a combination of the commutative and associative properties, I'm able to get here. And that's what we see here. That's what we have over here on the right. Does that make sense?
Yeah.
All right, sounds good. So that's why these two are equal. Now the question is, why do we do this? Why do we even do this in the first place? Livia, why do we do this?
Because 472 plus 219 plus 28, that means that it's equal to 472 plus 28 plus 219. So they're mostly the same thing. So you can use that equation and they mean the same thing.
Well, but why? Why would you even make it, a different question in the first place? Why would you spend that time to change the equation?
So you can make the question easier.
How is this easier?
Because if you do 472 plus 28, that equals 500, and you can just add it to 219 and make it 719.
Right, because if I do 472 plus 28, that first part's a lot easier than anything else, right? So the reason why we want to do this is because it makes the question simpler. It means that we don't need to add 219 and 28. It means we can go ahead and directly, add these two numbers, get 500 really easily. And then we get a really nice second step as well. So our answer here is 719, right? Imagine adding these two numbers together, right? That's so much more difficult than 472 plus 28, right? Adding those up, and then adding that to 472, that's a nightmare. So that's why this is important. Alan, do you have a question or did you want to answer?
I think it's also because sometimes you have the multiplication and then the addition.
Oh.
You have to do the multiplication first.
Okay. That's something that we're going to get into. That's something that we aren't talking about just yet, but that's something that we will bring up in a later chapter, in a later section, all right? So that's something that we're going to get to. So hold on to that. We'll get to that in a later week. All right. Any questions over 1.3 here? Any questions over how we made that change? Any questions over why we did that? I think Livia did a good job of actually explaining why we made that change here. All right, let's look at 1.4. 1.4. Let's hear from Alicia. Hopefully that's how you want me to pronounce it. Is it Alicia or is it Alicia? How about Ali then?
I was just looking at this problem and then I noticed an easy way to compute it.
So can you go ahead and read the question first?
Compute parentheses 2 plus 12 plus 22 plus 32 plus parentheses 8 plus 18 plus 28 plus 38.
So what is the easy way to do this? So the direct way to do this would be, add up these four numbers, add up these four numbers, and then add both of them together. But we don't want to do that, right? What do we want to do instead?
We can take the first two, like the two at the very beginning, and we can add it to the 38 at the very end.
What does that make?
That makes 40.
And
And then we can do 12, and then we can add it to 28, which makes 40. 50.
That's also 40, actually.
Oh, right. Wait, what? Oh, sorry. And then we can do 22 plus 18, which is also 40.
Right.
And then 32 plus 8 is also 40.
So that's just 40 plus 40, added 4 times, right?
Yeah.
So what's that equal to?
160.
Yeah. So here, right, another example of, and nice work here, right? So this is just another example of why you would, reorder the numbers, right? Add them in a different order than what's listed so that you can get an easier answer, right? We don't want to add up the numbers the direct way, right? We want to change up the order, add them in a different way so that we can get an easier question to work with. An easier question is much easier than if we, add it directly. But that's what we see here. Any questions over 1.4? All right. So that's about it here for the first 4 problems. If no questions over any of the first 4 problems, then we can continue on into the next ones. So now let's see what happens if we want to add together more than just that. What happens if we want to add together all the numbers from 1 to 20. So the ellipses here, the ... that just means all the numbers between them, all right? Let's hear from John.
1.5?
Yeah, 1.5.
Find the sum of 1 plus 2 plus 3 plus ... plus 19 plus 20. Reminder, the ellipses ... means that we should include all the numbers in the pattern. So we are adding the positive integers from 1 to 20.
So I've listed out a couple more numbers here. What do you recommend we should do here?
Wait, is 0 included?
It doesn't really matter.
Okay. I think we should do like 1 plus 19, 2 plus 18, 3 plus 17. And just
So what you're
keep
saying
on,
is,
yeah.
okay, so what you're saying is all of these numbers grouped together. And what does each
And then
group...
there'll be 10.
Right. So each one of these groups will be 10. 10?
No, 20. And then there'll be like a 10 by itself.
I see what you're saying. Okay. So what you're saying here is every single one of these numbers is going to pair up to equal 20, right? And once you add up all those pairs, you're going to get a 10 left in the middle, right? 9 and 11 are going to pair up for another 20. But then you're also going to have this 20 at the end, right? So how many sums of 20 are you going to have here?
Wait, 10?
Yeah, you're going to have 10 actually, right? For every number 1 through 9, you're going to have one group of 20. And then you're going to have a 10th one right here. So that's going to be 10 times 20. And then remember that 10 in the middle, right? So then we add on another 10. So how many numbers, what is the total of all these numbers going to be?
210.
And that's exactly it. So that is how we can do this, right? So instead of actually adding numbers one by one, right? So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, right? Instead of doing that, we can do things this way instead. Now, this is the way that I find a lot of people will do. I think that this one is really nice, especially since we end right at 20 and the numbers, they add up to 20 quite nicely, right? But what if instead of ending at 20, what if instead I said the numbers from 1 plus 2 plus 3 up to, let's say, 23 plus 24 plus, let's end at 23, actually. So plus 21 plus 22 plus 23. How would we do this instead? Sure, Brendan, do you want to do this one?
I think I know how to do this one.
You're pretty quiet. Can you move closer to your mic? Brendan? And he's gone. Okay. No, Brendan, I did call on you.
No, you called on me.
Brendan with an E? Yeah, I did call on you.
I know you called on me.
Yeah.
Is it? Can you hear me now?
Yeah, I can hear you now.
Okay. So I'm thinking that we can just like pair the 23 and 1 and then 22 and 2 and so on.
Yeah, so just directly pair up the first number with the last number every single time, right? So first number with last number, once those are paired, use the new first number and the last number, right? Pair up just these numbers here, right? So the idea is you just pair up these, right? So each sum here is going to be 24, right?
Yeah.
Okay, so how many 24s are there going to be here? So all the way in the middle, you're going to find an 11, a 12, and a 13. 11 and 13 are going to pair up for 24, and then 12 is going to be on its own, right? So how many pairs of 24s are there here?
11.
So this is going to be 24 times 11 plus
Mhm.
another 12. Is that right?
Yeah.
And that's going to be exactly it, right? We're going to actually find that this is equal to 24 times 23 divided by 2. And what this tells us is that for any one of these groups, the sum of the numbers 1 plus 2 plus 3 all the way up to plus n turns out to be equal to n times n plus 1 divided by 2. This is a formula that's really important if you want to do competitions. If you want to do something like the AMC or math counts, this is going to be a formula that you need to memorize. But that's what we see here. Any questions over 1.5? If not, then let's
I actually have something to add.
Sure.
If you want to times any number by 11, like that 24, you could do 24 plus 240.
Yeah. So this one is actually it's a multiplication kind of shortcut that you may have learned before. But the idea is if you have any number, let's say for example, 732,156. If you want to multiply this by 11, what you can do is you can just do 6 goes straight down, then you add these two numbers, add 2 numbers by 2 numbers, right? So 6 plus 5 is 11, so you carry a 1. 5 plus 1 plus the 1 you carried is 7. 1 plus 2 is 3. 3 plus 2 is 5. 3 plus 7 is 10. Carry the 1. 7 on its own now, plus that 1 that you carried is 8. So your answer here is this. 8,053,716. So that's another example of how you could do this. But yeah, so that's another trick that you could do. Okay. Last problem of this section. Let's take a look at 1.6. Let's hear from Elijah. 1.6. Elijah? Can you give it one more try? I don't think I heard you. Okay. Brandon then, I guess, with an A. Brandon?
Me?
No, the other one.
Sorry.
You're good. 1.6 real quick. This one should be quick.
Using the picture below, explain 2 plus 0 equals 2.
So how would you explain this?
Well, if 2 plus 0 equals 2, it's because 2 plus nothing equals 0. I mean 2, sorry.
Right, so the idea here is you can think of this as, 2 light squares plus 0 dark squares is equal to 2, right? And that's pretty much what we see here, right? 2 plus 0 is equal to 2. That's what we have right here. And that's something that we see here, right? So this principle really is just saying that if you add 0, you don't change your number, right? No matter what, if you add 0, you're not going to get any differences, right? So that's what we see here. Now, again, right? So everything that we covered in this chapter is something that you should have learned before, right? But the idea behind this chapter, right? The idea behind what we've covered in this section is we're really just kind of, rephrasing a lot of things that we've learned before, right? We're restating it, right? We're bringing it back up, right? And that's the whole idea behind chapter 1. We're going to reintroduce a lot of these topics because these topics are important. Now, starting in chapter 2, chapter 3, that's when we start to see new material. So chapter 1 is a lot of review. So, just hang on in there before we get into that new material, right? But with that, that's actually it here for section 1.2. And let's move on into section 1.3. 1.3 has a lot of the same ideas. We're going to see, instead of addition, we're going to see multiplication. Now, multiplication, if you guys remember, is just addition. It's repeated addition. In fact, if you may remember, something like 2 plus 2 plus 2 is the same idea as 3 times 2, right? It just means that we add 2 to itself 3 times. So that's the idea behind multiplication. In fact, we're going to find that for every rule that addition has, multiplication has the same one. So let's take a look at the problems here. Starting off with 1.7 through 1.10. Let's take a look at these problems here. 1.7. Rebecca.
Using the 2 pictures below, explain why 2 times 3 equals 3 times 2. So the 2 pictures below, the first one stands for 2 times 3 because it's 2 squares tall and then it's 3 squares like lining horizontally.
Yeah.
And then for the second one, it's basically the same thing but flipped, and so it's 3 and 2.
Right. And in both of these examples, how many squares do we have in total?
So each one has 6, and then 6 plus 6 equals 12.
Yeah, that's exactly it. Well, we don't care about the 6 plus 6 part, right? But the idea is each one of these is 6. Well, 6 is equal to 6, right? What property is this for multiplication?
This is the commutative property.
Exactly, right? So this is also going to be your commutative property, and that's what we see here, right? So commutative property of multiplication in this case. So remember, right, when we change the order of the numbers like we did here, right? First number times second number equals second number times first number, right? It doesn't matter, right? That's the same idea as what we saw in addition. It doesn't matter what order you add the numbers in either, right? It's the same idea here. It doesn't matter what order you multiply the numbers in here, right? And that's what we see here. Yeah, any questions here? So when we write out multiplication, what we can do, for example, like well, from now on, actually, we're gonna try not to use this cross very much, because the reason why is because that cross might look like an X, especially when you handwrite it. So from now on, multiplication, you're gonna try to use a dot. So for example, like A times B, right? Or just A, B like this. This also means multiplication. But when you write it out with numbers, try to include that dot, right? So like 3 times 4, like that. That's going to be what you're going to look for here. So that cross, we're going to try not to use that as much, but you might see it here and there in print because it might be easier to, recognize what that difference is. But yeah, so when we write it out by hand, I'm probably going to write the dot. That's going to be how I write that out. Right? Okay, 1.8. I believe I haven't called on Leanna. Leanna? No? Okay. How about I believe you go by Tyler, right?
Yes.
Okay, Tyler. 1.8. So can you read the question first?
Oh. By counting the dots in the picture below in two different ways, explain why 2 times 3 times 4 equals 2 times 3 times 4. Because they just switch the numbers that get multiplied. It's still the same thing. It's still just multiplying 2 times 3 times 4. There's not anything different. It will equal the same thing.
Okay, I kind of see what you're getting at here. But the idea here is, all right, so to kind of explain it using the picture, 2 times 3 first means that we're counting how many cubes we have in total. And then we're saying, okay, each cube has 4 dots. So that's how many dots we have in total. Counting how many cubes, and then per cube, how many dots, that gives us the total amount of dots. Here, if we do 3 times 4 first, we're saying how many dots are there per row, and then multiplying by the number of rows we have to give the total number. But the idea here is no matter what, you're going to get the same answer, right? It's going to be 24 no matter how you do it. So what property is this when it comes to multiplication?
Repetitive? No, commutative.
Commutative property was this one.
Then was it?
This was the associative property.
Oh.
So the commutative property of addition and associative property of addition have resurfaced here, right? Just with multiplication instead. And it's the exact same, right? If you change the order of the numbers, that was commutative earlier, it's still commutative now. If you add in, if you change the positioning of your parentheses, right? Same thing, it's still the associative property. So that's what we see here, right? It doesn't matter what order you multiply the numbers in. As long as you're multiplying numbers, you can multiply them in any order you want. But remember, that only is true as long as you are as long as you're multiplying numbers together. If you have any mix of multiplication and addition, that's when things need to stop. That's when things need to happen in the correct order, right? As long as you're multiplying numbers, you can multiply in any way you want. Let's take a look at an example with 1.9. 1.9. Yuhang. Sorry, I don't know exactly which pronunciations they are. So if you want to let me know, or if there's anything else that you go by, please let me know. That's the button to the left of that.
Oh, I was muted.
There you go. There you go.
Compute 25 times 125 times 4 times 6 times 8.
Okay. So 25 times 125 here is pretty hard, right? You don't want to do that. Would you agree?
Yeah.
So what should we do instead?
Do the smaller ones.
The smaller ones, if we do those first, we're still going to get something that's pretty difficult to work with, right? Because at the end, we're still going to need to do 25 times 125 at some point. So is there any way we can, similar to that addition, right? Similar to the addition questions, is there any way we can group the numbers together so that we get an easier answer? So that we get an easier question, I guess.
maybe break them into smaller numbers?
Have we talked about that at all here? No, not really, right? We haven't really talked about how to break up those numbers, right? So that's not going to be something that we're going to look at. We're only going to look at how to, combine numbers in a different order to make this easier. So what can we do here?
Can't we do 25 times 4, which makes 100? That makes
Yes, but this is his question. So let's hear him answer. For other people didn't answer your question, so please don't do the same don't do it for others. Okay, so Yuhang, what do we see here?
125 times 8 should small numbers times the bigger numbers instead of the big numbers times the big numbers.
Yeah, so the idea here is we can group up one of the smaller numbers with one of the big numbers to create something that's really nice to work with, right? In this case, if we work with that 125 times the 8, we can get 1,000, and 1,000's a lot nicer to work with than 125, right? And we can do the same thing for 25 times 4, and that would give us 100, right? So now we have 100 times 6 times 1,000, and what is that equal to?
600,000.
And that's exactly it. So that is our answer here, right? So the idea here is we want to group up these numbers in a way that makes a lot easier intermediate numbers to work with, and that's what we have: 6 times 100, then times 1,000. Okay, 1.10 is pretty quick. Explain why 2 times 1 is equal to 2. Well, we have 2 rows, 1 column. That's just 2, right? So the idea behind problem 1.10 is the same kind of idea as behind adding 0. You can multiply by 1 to get the same number. It does not change your answer, right? So this one and the addition by 0, these are what are called the identity properties. Identity property just means that the number stays the same. It stays identical. So that's what we see here. So multiplying by 1, adding by 0, these two are the same ideas. So this is one that does kind of change a little bit, right? So multiplying by 0 is not the same thing as adding by 0, right? So the identity properties are slightly different between addition and multiplication, and that's something that you do want to pay a lot of attention to. All right, we probably have enough time for 1 or 2 more questions. Oops, that's not what I meant to do. We probably have enough time for 1 or 2 more questions, so let's get that in here. So problem 1.11, and if we have time, 1.12. All right, 1.11. Let's hear from Jie. Oh, and they're gone. How about Guanhong?
Which one?
1.11, part A.
Okay, so A, compute parentheses 5 plus 6 in parentheses times 7. So equals 11 times 7, which is also equal to 77. Then compute 5 plus parentheses 6 times 7. 6 times 7 is also equal to 42, and then plus 5 is equal to 47.
Yep, and that's exactly it right here. So we have 77 and 47, but the idea here is we see that, between multiplication and addition, we do need to pay attention to what we do first, right? So we do need to be very careful about what we actually do first, because if we change the order of that around, we're going to get a different answer. Now, especially, even if you didn't have the parentheses, right, there is a way that you have to do this. So if we just wrote 5 plus 6 times 7 like this, we would actually have to do the multiplication first. We would not do this from left to right. We would have to do the 6 times 7 first to get 42, right? And the reason why this is the case is because of, I think it was Ali. I think you were mentioning this, right? But the way that I learned this was Pemdas with a P. So I learned Pemdas. But that stands for parentheses exponents multiplication, division, addition, and subtraction. So far, we've only seen multiplication, division, multiplication, and addition. We are going to see the rest later on. So I've also heard of gems. That's another one that I've heard of. The idea is grouping exponents, multiplication / division, subtraction / addition. That's another one that I've heard. But the idea here is multiplication and division happen at the same time. Addition and subtraction happen at the same time, but the rest of it happens from left to right. So that's why multiplication happens first. Again, this is something that you guys should be familiar with already, so I'm comfortable with just leaving it there. Yeah, you may have heard of it, in a lot of different ways, but these are just different ways that you may have heard of it. But with that, that's going to be all the time that we have here for this week. Homework for this week is going to be just section 1.2. Next time around, we're going to wrap up section 1.3 and we're going to go through as far as we can. I think we should be able to get to around section 1.5, maybe 1.6. But with that, that's going to be it here for this week. If you guys have any questions, feel free to stick around. Otherwise, that's going to be it here for today, and I'll see you all next week, same time.
Bye.
Yeah, for sure.
Bye.
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 See ya.
Thank you, teacher.
Yeah, for sure.